Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry O-Levels Multiple Choice, Paper 12 from May-Jun 2018. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. A student wants to show that the rate of reaction between calcium carbonate and dilute hydrochloric acid doubles for every 10 degrees centigrade rise in temperature. The method the student uses is to measure the volume of carbon dioxide released. The student has a Bunsen burner and a gas syringe. What other essential apparatus must the student use? In this experiment, the student wants to measure the rate of reaction. Now, rate needs time. It also needs the change in mass or the change in volume. In this experiment, the student measures the change in volume, not the mass. So for this volume of carbon dioxide, we need gas syringe. Secondly, we have calcium carbonate. Now calcium carbonate is in solid form and it needs to be measured. We would need apparatus for this one. Then we have dilute hydrochloric acid, which is liquid, so we would need to measure this volume of liquid. Next thing is the measurement of temperature. So for temperature, we need thermometer. So first thing is calcium carbonate. It is solid and it needs to be measured using balance. So balance is needed. In part C, we can see we do not have any balance. Again in D, we do not have any balance. For measuring time, we need stopwatch or clock. In part A, we can see there is no stopwatch or clock. In part B, it is given. Then we have temperature, for which thermometer is needed. And finally, for volume of hydrochloric acid, we can use measuring cylinder. So correct answer is part B. Question 2. Which mixture can be separated into its components by adding water, stirring, and then filtering? In part A, we have a mixture of calcium carbonate and sodium chloride. As we know that calcium carbonate is insoluble in water while sodium chloride is soluble to form aqueous solution. So we can add water. What will happen that sodium chloride will dissolve in water while calcium carbonate will be left behind. And upon filtration, calcium carbonate is separated as residue, while water will be gone in the filtrate. In this way, both can be separated, so therefore option A seems to be correct. In part B, we have magnesium metal and iron metal. Now both magnesium metal and iron metal is insoluble in water. So therefore, as none of them is soluble, they cannot be separated by adding water, stirring and filtering. Option C, we have sodium chloride and copper 2 sulfate. Now sodium chloride and copper 2 sulfate both are water soluble, so therefore they cannot be separated by dissolution in water and filtration. So option C is also incorrect. In part D, we have a mixture of sulfuric acid and hydrochloric acid. Again, both sulfuric acid and hydrochloric acid is water soluble and they cannot be separated by filtration. Correct answer is therefore A. Question 3. Which row gives the correct tests to identify both ammonia and sulfur dioxide? First one is the test to identify ammonia and second is the test to identify sulfur dioxide. For ammonia, we know that ammonia is base. And for base, you should remember that base turns red litmus to blue. So damp red litmus paper is turned to blue, so it is either C or D. Second thing is sulfur dioxide. Now sulfur dioxide is a reducing agent. Acidified potassium manganate 7 is oxidizing agent. Now what will happen is that potassium manganate 7 will oxidize sulfur dioxide to sulfur trioxide and itself it is converted from purple to colorless. So this is a correct test for identifying sulfur dioxide. Correct answer is therefore C. Question 4. Two gases, ammonia and hydrogen chloride at an equal pressure are allowed to enter the apparatus shown. This is HCl gas, this is ammonia gas, and white solid is formed when both of these react together. After a time, a white solid forms on the inside of the tube. Which statement explains why a white solid forms in the position shown? Now in this experiment, diffusion is taking place. HCl is a gas. The molecular mass of HCl is 1 for hydrogen, 35.5 for chlorine. So it is 36.5. While for NH3 we have 1 nitrogen whose atomic mass is 14 and 3 hydrogen atoms. So for 3 it is 3. So in total the molecular mass is 17. Now diffusion is inversely proportional to molecular mass. So diffusion of NH3 is faster as compared to the diffusion of HCl gas. So the distance covered by HCl is less as compared to the distance covered by ammonia. Now when both these gases come in contact, they form this solid NH4Cl, which is white in color. Let's move towards option 1. Ammonia and hydrogen chloride react to form solid ammonium chloride. This is correct. Part 2. Ammonia diffuses faster than hydrogen chloride. This is correct because molecular mass of ammonia is less than that of HCl. Part 3. Ammonia has a lower relative molecular mass than hydrogen chloride. All 3 options are correct. Answer is therefore A. Question 5. The atomic number of cerium is 58. A cerium plus 4 ion has 140 nucleons in its nucleus. How many protons, neutrons and electrons are there in one cerium plus 4 ion? Now we can write the given values. We have cerium, neutral. The proton number is 58. Atomic number is also the number of protons. The nucleon number is 140. So we can write 140. Now in neutral cerium, the number of proton is always equal to the number of electrons. So we have 58 protons and 58 electrons. But we can see that the given charge is plus 4, which means that 4 electrons are lost from neutral cerium. So 58 minus 4, it becomes 54 electrons. So we have 54 electrons and 58 protons. Now last thing is number of neutrons. Neutrons can be found by subtracting these two. 140 minus 58. So it comes equal to 82. So it is 82. Correct answer is therefore A. Question 6. The diagrams show the arrangement of particles in 3 solids. We have X, Y and Z. The 3 solids are krypton, potassium and sodium chloride. Which row correctly identifies X, Y and Z? Now looking at the structures of X, Y and Z, we can see that in X we have opposite ions. One is positive ion which is surrounded by negative ion. So this is the crystal lattice or the ionic lattice of ionic compound. In Y we can see that we have positive ions surrounded by a sea of negative electrons. So this is the structure of metal. In Z we can see that we have similar size of atoms and they are present close together. So therefore this is the structure of an element in solid state. From the given options we can see that krypton is an element, so therefore Z should be krypton. Krypton is a noble gas member. Second is we have potassium. Potassium is a metal, so therefore this is the structure of metal, so Y should be potassium. Third one is sodium chloride, as sodium chloride is ionic compound, so therefore X should be sodium chloride. So from options we can see that X should be sodium chloride, Y should be potassium, and Z should be krypton. Answer should be D. Question 7. Which statement about solid calcium chloride is correct? Now calcium chloride is ionic compound. As calcium is a metal and chlorine is a non-metal, calcium is from group 2 and chlorine is from group 7 of the periodic table. They make ionic bond between themselves. The structure of ionic compound is lattice structure, in which positive ions are surrounded by negative ions and negative ions are surrounded by positive ions. Part A, it conducts electricity. Now as calcium chloride is in solid form, so the ions are not moving and there are no free electrons present in ionic compound. So electricity can be conducted by two things. Either we must have free electrons or we should have moving ions. As ions are fixed in solid calcium chloride, so therefore it is bad conductor. Part B, it has a low melting point. As we can see that in lattice structure, positive and negative ions surround each other and there is larger electrostatic force of attraction, due to which the melting point is quite high. Part C, it has ionic lattice structure. This is true because ionic compound are present in ionic lattice structure. Part D, it is insoluble in water. This is incorrect because all ionic compounds are soluble in water. Correct answer is C. Question 8, we have ethane, C2H6 and ammonia, NH3. They are covalent compounds which are formed by the sharing of electrons. The dot and cross diagrams of these compounds are shown. This is ethane and this is ammonia. Which statements are correct? Number 1, a molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. Let's count the number of hydrogen atoms. We have 6 hydrogen atoms in ethane and 3 hydrogen atoms in ammonia. So therefore option 1 is correct. Option 2, an unreacted nitrogen atom has 5 outer electrons. Now nitrogen belongs to group 5 of the periodic table, and in group 5 the elements have 5 valence shell electrons. In the diagram we can see that X represents the electrons of nitrogen, as there are 5 X, so therefore it means 5 electrons are present. Statement 2 is also correct. Option 3, in a molecule of ethane, the bond between the carbon atoms is formed by sharing 2 electrons, one from each carbon atom. Now we can see in the diagram that this is the shared pair of electron between carbons. One electron is donated by one carbon while second electron is donated by second carbon, and a single bond is formed between these 2 carbon atoms. So therefore statement 3 is also correct. Answer is therefore A. Question 9, which statement about the structure or bonding of metals is correct? For metals you should remember electron C theory, according to which positive ions are present, surrounded by C of electrons. Part A, a metal lattice consists of atoms in a sea of electrons. It is not atoms, it is positive ions or positive nucleus. Part B, electrons in a metal move randomly through the lattice. This is true statement because electrons are free to move and they can move in any direction. Also, due to these free electrons, metals are good conductors of electricity. Part C, metals are malleable because the particles present are mobile. Now, malleability in metals is due to sliding of positive ions over each other. The positive ions are fixed and they are not mobile, so therefore this is wrong. When enough force is applied, what happens that same sized ions are slided over each other, due to which metals become malleable. Part D, the ions in a metal move when positive and negative electrodes are attached. Now conduction of current is due to the presence of free electrons. It is not due to the movement of ions. Only electrons move when positive and negative electrodes are attached, so therefore this statement is incorrect. Correct answer is therefore B. Question 10. When one volume of gas R reacts with exactly 5 volumes of oxygen, it forms carbon dioxide and water only. What is R? For reactions of gases, you can take volume as moles. So we can say that when 1 mole of gas R reacts with exactly 5 moles of oxygen, it forms carbon dioxide and water only. Let's write the balanced chemical equation. First one is butane. We have C4H10. It will combust in the presence of oxygen to form carbon dioxide and water vapors. Let's balance this equation. We have 4 carbon atoms, so we can write 4 with CO2. Now we have 10 hydrogen atoms, so we can write 5 with H2O to make it 10 hydrogens. Now we have 8 plus 5, 13 oxygen atoms on the product side, so we can make this 13 by writing 13 by 2. As 13 by 2 is more than 5, so therefore 1 mole of butane, it requires more than 5 moles of oxygen, so A is incorrect. In part B, we have ethane, C2H6. We have oxygen, it forms CO2 and H2O. Again, we can start balancing from carbon. We have 2 carbon atoms, so we can write 2 with CO2. Now we have 6 hydrogens, so we can write 3 with H2O to make it 6. Now we have 4 oxygen atoms in CO2 and 3 oxygen atoms in H2O. So in total we have 7 oxygen atoms in the product side. So we can write 7 by 2. As 7 by 2 is less than 5 moles, so therefore 1 mole of ethane requires less than 5 moles of oxygen, so B is also wrong. Option C, we have methane, CH4. Let's write the balanced equation for methane. Let's balance carbon. We have 1 carbon on the reactant side, 1 on the product side, so it is already balanced. We have 4 hydrogen atoms, so we can write 2 with H2O to make it 4. Now we have 4 oxygen atoms, so we can write 2 with oxygen to make it 4. Now 1 mole of CH4 requires 2 moles of oxygen, or we can also say that 1 volume of CH4 requires 2 volumes of oxygen for complete combustion. This is also wrong. Last one is propane. We have C3H8. Again, it reacts with oxygen. We have 3 carbon atoms, so we can write 3 with CO2. We have 8 hydrogen atoms, so we can write 4 with H2O. Now we have 6 and 4, 10 oxygen on the product side, so we can write 5 with O2 to make it 10. Now we can see that 1 volume of propane requires 5 volumes of oxygen. So this is according to the statement. Correct answer is D. Question 11. The relative molecular mass of a compound is 166. What is possible molecular formula of this compound? Let's find out the molecular masses of all these given compounds. In A, we have C4H3O2, so we have 4 carbon atoms, 3 hydrogen atoms, 2 oxygen atoms. The atomic mass of carbon is 12, so 4 into 12 become 48. 3 into 1 forms 3. 2 into 16 for oxygen, it is 32. So molecular mass of A comes equal to 83. A is therefore incorrect. For part B, we have 6 carbons, 4 hydrogens, 4 oxygens. So 12 into 6 is 72. 4 into 1 is 4. 16 into 4 is 64. So it comes equal to 140, which is also incorrect because it should be 166. For part C, we have 6 carbon atoms, 8 hydrogen atoms, 2 oxygen atoms. So 12 into 6 is 72, 8 into 1 is 8, 2 into 16 for oxygen is 32. So the molecular mass comes equal to 112. Again, this is wrong. Last one is part D. We have 8 carbons, 6 hydrogen atoms, 4 oxygen atoms. So 12 into 8 is 96, 6 into 1 is 6, 4 into 16 is 64. The molecular mass comes equal to 166. So this one seems to be correct. Answer is D. Question 12. A mass of 63 grams of KMnO4 potassium manganate 7 is needed for complete oxidation of 23 grams of ethanol under acidic conditions. How many moles of ethanol can be completely oxidized by 1 mole of potassium manganate 7 under these conditions? So we have potassium manganate and ethanol. We can find the reacting number of moles by using this mass which is given and the molecular masses of these compounds. In KMnO4 we have 1 potassium, potassium is equal to 39, 1 manganese which is equal to 55, and we have 4 oxygen atoms, so 16 for 1 oxygen and for 4 it will be 64. Adding all these together, the molecular mass comes equal to 158. Now we can find the number of moles of KMnO4. The formula is number of moles is equal to mass in grams divided by mR. Mass in grams is given, it is 63, and mR is calculated, which is 158. So the number of moles of KMnO4 reacted in this reaction is equal to 0.398. Now doing the same for ethanol, we have 2 carbon atoms, so 2 into 12. We have 5 hydrogen atoms, so 1 into 5. 1 oxygen, 16, again 1 hydrogen in the last, so it is 1. Adding all these together, the molecular mass comes equal to 46. Now we can find the number of moles of ethanol by using this mass. Number of moles is equal to mass in grams divided by molecular mass, so mass in grams is 23. Molecular mass given is 46. So number of moles come equal to 0.5 moles. Now we can say that 0.398 moles of KMnO4 react exactly with 0.5 moles of ethanol. Now in the question we have to find out how many moles of ethanol can be completely oxidized by 1 mole of KMnO4. So for 1 mole it will be equal to X. By cross multiplying we can find the number of moles of ethanol. So we have X into 0.398 equals 0.5. So the number of moles of ethanol comes equal to 1.25 moles. Correct answer is therefore D. Question 13. The diagram shows an electrolysis experiment using inert electrodes. Before electrolysis this was the case, and after electrolysis we can see that gases are formed. On negative electrode more volume of gas is produced as compared to the positive electrode. What could be liquid? Why? In A we have aqueous copper 2 sulfate. In aqueous copper 2 sulfate we have copper plus 2. We also have sulfate, and as we have water, so we have H plus ions and OH negative ions. Now among cations we have copper plus 2 and H plus, and among these two cations copper plus 2 easily gains electrons as compared to H plus. So therefore copper plus 2 will be discharged to form copper solid, and as copper plus 2 is cation it will move towards cathode to form copper solid. No hydrogen gas is formed at cathode. As in diagram we have seen that at both electrodes gas was formed, so therefore A is incorrect. Part B is concentrated aqueous sodium chloride. Now we have sodium ions, chloride ions that are present in larger amount as it is concentrated. We also have H plus and OH negative from water. Now among cations, H plus is easily discharged as compared to sodium plus from the discharge series. So we can say that hydrogen gas is formed at the cathode. The reaction will be like this. We have H plus. It will gain electron to form hydrogen. Now among anions, the concentration of chloride is higher than the concentration of OH negative. So therefore chloride ions will move towards anode and they will lose electrons to form chlorine. We can also balance this one. Now in the reactions we can see that the number of electrons gained and lost are equal, and one volume of hydrogen is formed and one volume of chlorine is formed. The volumes formed are equal, while in the diagram the volumes were not equal. Therefore B is also incorrect. In part C we have dilute sulfuric acid, so we have H plus ions from sulfuric acid and H plus ions from water. We also have sulfate ions from sulfuric acid and OH negative ions from water. As we have only H plus as cation, so cation will move towards cathode to form hydrogen gas. It will gain electrons to form H2. Among anions, we know that sulfate ions are not discharged, only hydroxide ions are discharged, so the equation will be like this. OH negative will move towards anode and it will lose electrons to form water and oxygen. We can balance this equation by writing 4 with OH negative and 4 electrons are lost. 2 moles of water is formed and 1 mole of oxygen gas is formed. Now as we can see that the number of electrons gained were only 2 while the number of electrons lost are 4. So we can balance the number of electrons gained and lost by multiplying this equation with 2. So when it is multiplied by 2, the volumes of hydrogen gas will be doubled as compared to the volume of oxygen gas. And as H plus is cation, it will move towards cathode and more volume of hydrogen will be produced, and OH negative is anion, so it will move towards anode and less volume of oxygen will be produced as compared to hydrogen. So option C seems to be correct. In part D we have ethanol, as ethanol does not conduct electricity, so therefore electrolysis cannot take place. Correct answer is therefore C. Question 14. Magnesium can be produced by the electrolysis of molten magnesium chloride MgCl2. What are the products formed at the anode and at the cathode during the electrolysis of molten magnesium chloride? In magnesium chloride we have Mg plus 2 ions present and Cl negative ions that are present. Now Mg plus 2 is cation and cation always moves towards cathode. And at cathode what happens is that reduction takes place. You can remember this by this word red cat. So reduction always occurs at cathode. Second part is anion. Anion moves towards anode and oxidation takes place at anode. Now oxidation is loss of electrons while reduction is gain of electrons. So Mg plus 2 will move towards cathode. What will happen that it will gain 2 electrons from cathode and it is converted into magnesium metal. So at cathode magnesium is formed. Similarly at anode Cl negative will move. It will lose its electrons and form chlorine gas. 2 number of chloride ions form 1 molecule of chlorine along with 2 electrons lost. So at anode we have chlorine. Correct answer is B. Question 15. The diagram shows apparatus that can be used to extract aluminum from its ore. What are J, K and L? This is J, this solution is K and this is L. Now you must know the names of these. J is black in color and it is carbon anode, which is positive. K is electrolyte, that is electrolyzed using this electrolysis process, as it is aluminum ore. So therefore K consists of aluminum oxide dissolved in cryolite. High temperature is present, so therefore this is in molten form. Temperature is about 950 degrees centigrade. L is liquid aluminum, which is taken out from here. This inner lining portion is of carbon cathode. Now we can see that J is carbon anode, which is positive. So J is positive electrode. K is the electrolyte, that is aluminum oxide along with cryolite. Cryolite is added to reduce the melting point of aluminum oxide. L is molten aluminum as it is separated. Correct answer is therefore D. Question 16. A reaction is exothermic. Which diagram shows the correct energy profile diagram for the reaction and correct enthalpy change? In exothermic reaction, heat is released into surroundings. Or we can say that due to release of heat, the energy of product is less than the energy of reactants. This is because the energy is released in the form of heat, so therefore the product is now at lower energy as compared to the reactants in exothermic reaction. Second thing is enthalpy change. For exothermic reaction, enthalpy change, which is delta H, it is measured by using energy of product minus energy of reactants. Now as we can see that the energy of product is always less than the energy of reactants in exothermic reaction, so therefore delta H is always negative. Let's move towards these diagrams. First thing is the energy of reactants. This is reactant and this is the product. Now the energy of product should be less than the energy of reactant, so therefore A is incorrect. Similarly in B you can see that the energy of product is not less than the energy of reactants, so this is also wrong. In part C and part D we can see that the energy of product is less than the energy of reactant, but in part C enthalpy change is positive, which is incorrect. It should be negative. Correct answer is therefore D. Question 17. Which fraction of petroleum, which is crude oil, is used as a fuel in aircraft engines? We have different fractions. First one is bitumen. Now bitumen is used for road surfacing. Part B is naphtha. Naphtha is used as feedstock for chemicals. Part C is paraffin, which is also known as kerosene. It is used as aircraft fuel. Part D is petrol, which is gasoline. It is used as fuel for cars. Correct answer is C. Question 18. The equation for photosynthesis is shown. We have 6 moles of carbon dioxide that react with 6 moles of water to form 6 moles of oxygen along with 1 molecule of glucose. Which statement about photosynthesis is correct? Part A, it has a negative enthalpy change. Now we know that in photosynthesis what happens is that energy is absorbed in the form of sunlight. So when energy is absorbed, it is not negative enthalpy change, it is positive enthalpy change. Part B, it is catalyzed by the presence of yeast. Now yeast is not used as a catalyst in photosynthesis, actually chlorophyll is used, which is present in green pigments of plants. Part C, the products of photosynthesis are oxygen and starch. We have the product which is oxygen and this is glucose, it is not starch. Last one, it occurs in green leaves, and this is true because chlorophyll is present in green parts of plants, which is leaves and stems. Correct answer is therefore D. Question 19. Compound X reacts with an acid to produce sulfur dioxide gas. A sample of X is placed in a flask and acid is added. The sulfur dioxide produced is collected and its volume is measured at various times. A graph of results is plotted. This is the graph. We have volume of sulfur dioxide that is formed in centimeter cube on y-axis, and we have time on x-axis. We can see that after a certain time the reaction stops. Which statement about this experiment is correct? Part A, the gas can be collected by displacing water from measuring cylinder. Now this is sulfur dioxide gas and sulfur dioxide is highly soluble in water. So for soluble gas we do not use displacement of water. Part B, the mass of the reaction flask and its contents decrease as the reaction proceeds. Now this statement is correct because gas is being formed as one of the product and it is collected. So therefore mass of reaction mixture is reduced. Part C, the rate of reaction increases as time increases. Now this is incorrect statement because rate of reaction can be seen by the steepness of this curve. Now as time increases the steepness becomes less, so therefore rate of reaction decreases with time. Part D, the reaction is still proceeding after 8 minutes. Now we can see that after 5 minutes the reaction stops because the line becomes straight. So the reaction has stopped. Only correct answer is B. Question 20. Which reaction involve oxidation and reduction? Part 1. Chlorine gas reacting with potassium iodide. Now we have chlorine on one side and iodine on the other side. Now in halogens we know that their activity decreases down the groups, so chlorine is more reactive than iodine. So chlorine can easily displace iodine to form compound. The reaction will be like this. We have Cl2. It will react with potassium iodide, aqueous. Chlorine will displace iodide, so it will form potassium chloride along with iodine. Now oxidation state of a molecule is always 0. So for chlorine and for iodine it is 0, while for potassium it is +1 as it is in group 1 of the periodic table. For iodine it is -1 as it is in group 7 of the periodic table. Similarly for potassium and chloride. Now chlorine goes from 0 to -1. This change in oxidation state from 0 to -1 is called reduction, while the increase from -1 to 0 is called oxidation. So 1 is correct. Part 2, dilute sulfuric acid reacting with magnesium. Now we can write the chemical reaction. We have metal magnesium, dilute sulfuric acid H2SO4. Now magnesium can react with sulfuric acid. It is acid-metal reaction to form salt and hydrogen gas. Magnesium sulfate salt is formed along with H2. Now looking at the oxidation states, the oxidation state of metal and molecule is always 0. In H2SO4, hydrogen is +1, SO4 is -2. In magnesium sulfate, as magnesium is from group 2 of the periodic table, so it is +2 and sulfate is -2. Now moving from 0 to +2 is oxidation, while moving from +1 back to 0 is reduction. So as both oxidation and reduction takes place in second one, so this is also correct. Part 3, dilute hydrochloric acid reacting with aqueous sodium hydroxide. This is neutralization reaction. We have HCl and sodium hydroxide. Now acid and alkali, they both react to form salt, which is sodium chloride, along with water. Let's find out the oxidation states. In HCl, hydrogen is +1, Cl is -1. In NaOH, sodium is +1 as it is from group 1 of the periodic table. Oxygen is -2, hydrogen is +1. In NaCl, Na is +1, Cl is -1. In H2O, 1 hydrogen is +1 and oxygen is -2. So we can see that no change in oxidation state has occurred. All the oxidation states in the reactants and products are same. So therefore 3 is incorrect. Correct answer is therefore B. Question 21. Nitrogen reacts with oxygen in an equilibrium reaction. This is equilibrium. Enthalpy change is positive, which means that the reaction is endothermic in nature. When the reaction is at equilibrium, which statement is correct? Part A. The concentration of nitrogen present will change with time. Now in an equilibrium reaction, the rate of forward reaction is equal to the rate of backward reaction, and at equilibrium the concentration of reactant and concentration of product is always constant. It does not change with time. B. The forward and backward reactions are taking place at the same rate. This is true because at equilibrium the rate of forward reaction is equal to the rate of backward reaction. C. The forward reaction releases heat energy. Now we can see that the reaction is overall endothermic. It means that forward reaction is endothermic, so forward reaction absorbs heat energy. Option D. There are more molecules on the left hand side of the equation than on the right. Now number of molecules can be found out by finding number of moles. Greater number of moles means greater number of molecules. Now we have 1 mole of nitrogen, 1 mole of oxygen, so in total we have 2 moles of reactants. We also have 2 mole of products, so therefore number of molecules on both sides will be equal. Correct answer is therefore B. Question 22. Lead oxide, which is PbO, reacts with dilute nitric acid, neutralizing the acid. Lead 2 oxide also reacts with aqueous sodium hydroxide, neutralizing the alkali. Which word best describes lead 2 oxide? Now any substance that reacts with both acid and alkali is called amphoteric substance. Acidic oxide can only react with alkali, it cannot react with acid. Alkaline oxide can only react with acid, it cannot react with alkali. Similarly, basic oxide can only react with acid, it cannot react with alkali. Correct answer is C. Question 23. Which pair of reagents are most suitable for the laboratory preparation of copper 2 chloride? Now this copper to chloride salt is soluble in water. Part A, aqueous copper to nitrate and aqueous sodium chloride. Now copper nitrate can react with sodium chloride. Both are soluble, so therefore both are aqueous in nature. And they react to form sodium nitrate, which is soluble salt, along with copper chloride, which is also soluble. Now we have two products, both are salts and both are soluble, so therefore it is difficult to separate out this one from this one, so therefore A is not correct. B, copper and chlorine. Now copper metal is below in reactivity series as it is very less reactive in nature, so therefore it cannot react directly with chlorine to form copper chloride. Part C, again we have copper metal and dilute hydrochloric acid. Now copper metal is very less reactive, so therefore it cannot displace hydrogen from dilute hydrochloric acid to form copper chloride salt. Part D, copper to oxide and dilute hydrochloric acid. Now copper oxide is a base which is insoluble and dilute hydrochloric acid is HCl aqueous. Let's find out this reaction. We have CuO, HCl aqueous. In this reaction we have acid and basic oxide, so we are going to use this one in excess so that none of HCl remains. The product formed will be copper chloride along with water. Now copper chloride is soluble salt and water is liquid. Now as copper oxide was used in excess so that all of HCl reacts with copper oxide, so there is no HCl left after this chemical reaction. We have copper oxide solid which was in excess, so it can be removed by filtration as it is insoluble in water. Third thing is copper chloride salt in water, so we can simply use crystallization process to obtain the crystals of copper chloride. Correct answer is D. Question 24. The compounds shown can be used as nitrogenous fertilizers. Which compound has the lowest percentage by mass of nitrogen? To find the percentage by mass of nitrogen, we can use this formula, percentage by mass of nitrogen. It is equal to the atomic mass of nitrogen into its number of atoms present in the compounds divided by the molecular mass of the compound into 100. So in part A we can see that we have 2 nitrogen atoms. In part B again we have 2 nitrogen atoms. In third one we have 3 nitrogens. In fourth one we have these 2 nitrogens present. Now using this formula, the atomic mass of nitrogen is 14 from periodic table. The number of atoms are 2. MR of this compound is given as 60 into 100. It comes equal to 46.67%. Similarly for part B we have 14 atomic mass of nitrogen into number of atoms which is 2 divided by MR of this compound which is 132 into 100. So it comes equal to 21.21%. For part C we have 3 nitrogen atoms. So 14 into 3 divided by 149 into 100. It is 28.18%. Similarly for the last one we have 2 nitrogen atoms. So 14 into 2 divided by the MR of this compound which is 80 into 100. So it comes equal to 35%. Among these percentages we can see that the lowest is in this one, so therefore answer is B. Question 25. The diagram shows 3 steps in the manufacture of sulfuric acid. In which steps is a catalyst used? Now catalyst is used in a reversible reaction in which sulfur dioxide, it reacts with oxygen in the presence of vanadium pentaoxide, which is V2O5, to form sulfur trioxide. As this is the only step in which catalyst is used, so therefore this is step Q. Answer is therefore C. Question 26. Indium, which has proton number 49, is in group 3 of the periodic table. Antimony, whose proton number is 51, is in group 5 of the periodic table. Which statement comparing indium and antimony is correct? Part A. Antimony has more metallic character and more valency electrons per atom than indium. Now metallic character depends on the size of atom. Greater size means larger metallic character and smaller size means less metallic character. As moving from group 3 to group 5, the atomic size decreases, so therefore metallic character also decreases. So therefore antimony should be less metallic than indium. Second thing is the valence electrons. Now valence electrons can be found out from group number. As indium is in group 3, so there are 3 valence electrons, while antimony is in group 5, so we have 5 valence electrons. So antimony has more number of electrons as per indium. This part is correct. The first part was wrong, so therefore statement is incorrect. Part B. Antimony has more metallic character. Again this is incorrect because the size of antimony is less than the size of indium, so therefore antimony has less metallic character than indium. And indium has more valence electrons per atom. This statement is also incorrect because the group number of indium is 3 while the group number of antimony is 5. Part C. Indium has more metallic character. Antimony has more valency electrons per atom. Now atoms of indium are larger in size as compared to antimony, so therefore this is correct. Antimony has more valency electrons. The group number of antimony is 5, so it has 5 valence electrons. This is true. In part D, the first part is true, while this is incorrect because indium has less valence electrons than antimony. Correct answer is C. Question 27. The position of 4 elements are shown on the outline of part of the periodic table. Which element is a solid non-metal at room temperature and pressure? This is the periodic table and these are the elements. We have A, B, C and D. From periodic table we can find out the groups and periods. This is group 3. Then we have group 4, 5, group 6, group 7 and this is group 8 or group 0. Then in periods we have first period, second period, third period, fourth and fifth period. Now looking at the periodic table, in group 3 and period 3 we have element which is aluminum. In group 6 and period 2 the element present is oxygen. In group 7 and period 3 the element present is chlorine. In group 7 and period 5 element present is iodine. Now A is aluminum and aluminum is a solid metal, so therefore A is incorrect. B is oxygen and oxygen is not solid, it is in gaseous form, so it is also incorrect. Again chlorine is also in gaseous state, while iodine is the only element that is solid non-metal at room temperature and pressure. Therefore correct answer is D. Question 28. 3 elements each show oxidation states of +2 and +3. To which part of the periodic table do these elements belong? As we can see that each of the 3 elements show more than one oxidation state, so therefore all 3 elements must belong to transition metals. because transition metals always show variable oxidation states. The oxidation state of group 2 is +2 and it is fixed. For group 3 it is +3, it is fixed. For group 5 it is either +5 or -3. Correct answer is therefore D. Question 29. Brass is an alloy. Which statement about brass is correct? Now brass is an alloy and it is made up of copper and zinc. Both copper and zinc are metals. Copper is about 70% while zinc is about 30% of brass. Statement A, it contains a sea of electrons. As brass is made up of metals, so therefore metals consist of sea of electrons. So statement A is correct. Part B, it contains positive and negative ions which are free to move. This is incorrect because negative ions are not present in metals. C, it is a compound of metal and non-metal. Now it is not a compound as alloy is always a mixture. In D, again it says it is a compound, which is incorrect statement. Correct answer is therefore A. Question 30. Copper 2 oxide, which is base, it reacts with carbon when heated. Now carbon reduces oxide of copper to form copper metal and carbon dioxide gas. Which statement about this reaction is correct? A is that carbon is oxidizing agent and B says that carbon is reducing agent. Now we can see that carbon has removed this oxygen and itself it has oxidized into carbon dioxide. So therefore it is behaving as a reducing agent. Reducing agent reduces other compound and itself it gets oxidized. So part A is incorrect while part B is true. Part C, copper oxide is oxidized. Now we can see that copper oxide has converted into copper metal, so oxygen is lost. Loss of oxygen is reduction, it is not oxidation. Part D, copper oxide is the reducing agent. Now as we can see that copper oxide itself gets reduced, so therefore this is oxidizing agent. Correct answer is therefore B. Question 31. The diagram shows a cell that can be used to extract a metal from its oxide. This is electrolysis process. We have anode. We also have cathode that is lined. We have molten electrolyte that is present. Molten aluminum oxide, copper 2 oxide, lead 2 oxide, magnesium oxide are each electrolyzed in separate cells. Each cell receives the same number of electrons. Which statement is correct? In these molten oxides we have aluminum +3 in aluminum oxide, copper +2 in copper oxide, lead +2 in lead oxide, magnesium +2 in magnesium oxide. Part A, all the metals can also be extracted from their oxide using coke. Coke is in fact carbon. This depends on the reactivity of metal as compared to carbon. So in reactivity series we have potassium, sodium, calcium, magnesium, aluminum. Then we have zinc, iron, lead, copper and silver. Now only the elements that are below aluminum can be extracted using carbon. Carbon is unable to reduce the oxides of these elements that are above in reactivity series because they are highly reactive metals and their oxides are quite strong. So all metals cannot be extracted by using carbon. This statement is wrong. Part B, the anode and cathode should be made of the metal being extracted. This statement is also incorrect because the cathode and anode should be made of graphite, which is carbon. Other than extraction, there is another process called electrolytic purification. In that process, anode is made up of impure metal and cathode is made up of pure metal. So therefore, in extraction, metals are not used as electrodes, only graphite is used. Part C, the pure metal is always produced at the cathode. Now we have these cations and you should remember this red cat. Reduction always occurs at cathode. Now these cations will move towards cathode. They will gain electrons to form respective metal. Aluminum plus 3 will gain 3 electrons. It will form aluminum. Copper plus 2 will gain 2 electrons. It will form copper. Similarly, lead plus 2 will form lead. Magnesium plus 2 will gain 2 electrons to form magnesium. So pure metal is formed at cathode. This is true statement. Part D, the same mass of each metal is formed. Now the mass depends on two things. One is the electricity, which is the number of electrons. As we can see that each cell receives the same number of electrons, so it does not affect the mass. Second thing is the atomic mass of the element. As the atomic mass of each element is different, aluminum is different than copper, it is different than lead and magnesium. So therefore, same mass is not formed, different masses are formed for each metal. Correct answer is therefore C. Question 32. Iron is obtained in the blast furnace from the ore hematite. Which process takes place in the blast furnace? Part A. Calcium carbonate is used to remove acidic impurities. This is correct because calcium carbonate first decomposes into calcium oxide and carbon dioxide. This calcium oxide is used to remove acidic impurities such as silicon dioxide. It will react with SiO2 to form slag of calcium silicate, which is then removed. B. Coke is reduced to carbon dioxide. Now coke is pure carbon and carbon cannot be reduced to carbon dioxide. It is oxidized to carbon dioxide. Part C. Hematite is oxidized by carbon monoxide. Now carbon monoxide is a reducing agent. It reduces hematite to iron. The reaction can be written like this. We have hematite, which is iron oxide. It can react with reducing agents such as carbon monoxide and it will form iron along with CO2. The equation can also be balanced. So hematite is reduced by carbon monoxide. This statement is wrong. Part D. Hematite undergoes thermal decomposition. This is incorrect because hematite does not undergo thermal decomposition. It undergoes a reduction reaction. Correct answer is A. Question 33. Aircraft manufacture requires a metal that has relatively low density and is resistant to corrosion. Which of these conditions does aluminum satisfy? For aluminum, you should remember that it has relatively low density as compared to other metals. It is also resistant to corrosion as it forms a layer of aluminum oxide which is insoluble in water. Low density of aluminum is due to its low atomic mass, which is almost equal to 27. So as compared to other transition metals, it has lower density. Correct answer is therefore A. Question 34. Which pair of gases are both non-acidic? Now, non-acidic means that the gases can be basic or the gas can also be neutral. Option A, we have ammonia and methane. Ammonia is a basic gas while methane is neutral gas. So A could be correct option. B is carbon dioxide, which is acidic. So this is incorrect because both should be non-acidic. In part C, we have methane, which is neutral, and nitrogen dioxide. Again, nitrogen dioxide is acidic, so therefore this is also incorrect. In D, we have nitrogen dioxide and carbon dioxide. Both are acidic in nature, so D is also wrong. Correct answer is therefore A. Question 35. Seawater is desalinated to make it drinkable. What is the main substance removed by desalination? Now the word desalination means removal of salt. So it is actually salt that is removed, and the most soluble salt is sodium chloride, which is present in larger quantities in seawater. So correct answer is D. Question 36. Which diagram shows a branched chain isomer of butane? Butane is 4-carbon alkene, which is C4H10. This is straight chain. These are the number of hydrogen atoms attached in butane. Let's find out the branched chain isomer of butane. So we have 4 carbon atoms. As we can see that this carbon is in branched form, so it could be A. In B, we can see that all 4 carbon atoms are in continuous chain. There is no branching that is present. Similarly, in part C, we can see that this is continuous chain and it consists of 4 carbon atoms, so there is no branching present. Again, in D, 1, 2, 3, 4, we have continuous chain of carbon atoms, so therefore this is not branched isomer. The only branched isomer is A. As we can see that there are 2 chains of carbon atom, one is this one and one is this one. Now for isomer, you should know that it means same formula but different structure. As we had 4 carbon atoms, 10 hydrogen atoms, and all carbon atoms were in one chain, straight chain, while in this one we have 4 carbon atoms, we have 10 hydrogen atoms, and we have a branched chain, so therefore A is correct. Answer is A. Question 37. A straight chain alkene C4H8 undergoes an addition reaction with bromine. What is the possible structure of the product? We can draw the structure of C4H8. We have 4 carbon atoms, 8 hydrogen atoms. Now the structure could be like this, that the double bond is present between first and second carbon, or the structure can be like this if the double bond is present between second and third carbon. Again, if the double bond is present at this corner, it will be similar to this one, because then numbering will start from this corner carbon atom. Now it reacts with bromine in addition. To form addition product, we have Br2. One bromine is attached to first carbon, that is making double bond. Second bromine is attached to second carbon, that is present in the double bond. Similarly for this one, again we have Br2 molecule. Each bromine atom is attached to the adjacent carbon atoms that are making double bond. I'm not showing the number of hydrogen atoms. Let's make the product. We have this one and we have this one. Now double bonds are converted into single bonds and bromine atoms are attached. Part A, we can see that one bromine is attached to this carbon atom while the other bromine is attached to the last carbon. This is incorrect because bromine molecule always attaches itself with the adjacent carbon atoms. In second one, we can see one bromine is attached to this carbon and second is attached to this carbon. As these carbons are adjacent, so B could be correct. In part C, we can see that one bromine is attached to this carbon atom. Second bromine is attached to the last carbon, which is wrong. Again for D, we can see that only one bromine is attached, which is also incorrect. So D and C are incorrect. Similarly, in A, we can see that adjacent carbons are not used. Let's find out this product. We have this one as first carbon, then we have second carbon, then third, and then fourth. We have 4 carbon atoms. So bromine is attached to second and third one, so it could be this product. This is first carbon, this is second, this is third and fourth. Let's draw the number of hydrogen atoms. With first carbon we had 3 hydrogens, with second one we had 1 hydrogen, similarly 1 for this one and 3 for this one. So we have CH3, CH, again CH, CH3. We can also write this product as CH3. Then we have this CH, then Br, which is substituent. Then we have CH, again Br, then CH3. So this is similar to this one. Correct answer is B. Question 38. The diagram shows the structure of oxalic acid. This is oxalic acid. We have 2 functional groups. C double bond OOH is carboxylic acid functional group. Similarly, this one is also C double bond OOH carboxylic acid functional group. Which alcohol is oxidized to form oxalic acid? Now we have 2 carboxylic acids that are present. Each carboxylic acid consists of just 1 carbon. 1 carbon is present in this one, 1 carbon is present in this one. So 1 carbon carboxylic acid it can only be formed from 1 carbon alcohol. 1 carbon alcohol, when oxidized, it forms 1 carbon carboxylic acid. So for this carboxylic acid we need 1 carbon alcohol. Again for this carboxylic acid we would need 1 carbon alcohol. And the total number of carbon should not exceed 2. In A we can see we have 2 carbon atoms. This is alcohol functional group. And it is 1 carbon alcohol which will form this carboxylic acid group. But this carbon does not consist of alcohol, so therefore it is not oxidized to this one, so A is incorrect. In part B we can see we have 3 carbon atoms, which is wrong because the number of carbons should not exceed 2 as the product is of 2 carbon atoms. In these 3 carbon atoms only this middle carbon is alcohol as OH is present with this carbon. So this one is oxidized to carboxylic acid while these 2 are not oxidized as no alcohol is present with these 2. So B is incorrect. In part C we can see that we have 2 carbon atoms. Each carbon atom has OH group attached, so this is 1 carbon alcohol. Again this is also 1 carbon alcohol. So this is oxidized to carboxylic acid, this is also oxidized to carboxylic acid. Part C seems to be correct. In part D we have 4 carbon atoms. These 2 are converted into carboxylic acids. But there must be 2 more carbon atoms that should be present in the product, which is not possible. So D is wrong. So this product oxalic acid can only be formed from part C. Question 39. Some properties of compound J are listed. Number 1 is that it reacts with potassium carbonate to produce carbon dioxide. Second is that it reacts with ethanol to produce a sweet smelling liquid. Third is that it reacts with sodium hydroxide to produce a salt. What is the possible identity of J? Now for first one we know that carbonate reacts with acid to produce carbon dioxide. In second property we know that ethanol reacts with carboxylic acid to produce esters. Ester is a sweet smelling liquid. From third option, we can infer that sodium hydroxide is an alkali, so alkali reacts with acid to produce a salt along with water. So compound J is acid, it is not alcohol, it is not ester. Correct option is therefore A. Question 40, the diagram shows the formula of nylon. We have 4 CH2 groups and on each side we have carbonyl carbon. Then we have 6 CH2 groups and on each side we have nitrogen bonded to hydrogen. From which compounds could nylon be made? Now this polymer should be made from monomers. Let's see which monomers should be present in this polymer. We can break this polymer into two parts. One is this portion that consists of C double bond O connected to these 4 CH2 groups. In the second part we have nitrogen that is connected to 6 CH2 groups on each side. And again we are going to repeat the first part and then again the second part and so on. In first portion of the polymer we can see that we have 4 CH2 groups. So it is not 6, it should be 4. In third one we have 4, in last one we have 6, so this is incorrect. Similarly on nitrogen side we can see that we should have 6 CH2 groups. These are 6, these are 4, this is 6, this is 4. C double bond O is formed from carboxylic acid. This is carboxylic acid functional group CO2H. It can also be written like this, C double bond O, OH, or CO2H, or it can also be written like this in inverted form. In second compound we have NH2. In first we have CO2H. Now carboxylic acid is CO2H and this is NH2. Both react together in condensation reaction to form water molecule. This is removed in the form of H2O. And the rest polymer is like this. We have C double bond O, then we have nitrogen, then we have hydrogen. So we can see this one is the product of condensation reaction. Correct answer is part C.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.